Unit 3 review, coordinate geometry. Okay, let's see here. Oh, I just clicked back. Right. Okay, find the length of segment from A to B. This is a diagonal line, which means that we need to use Pythagorean Theorem. So we're going to go straight down and over. Now we have a right triangle. So from A down to B, let's count down. We're at 1, 2, 3, 4, 5, 6, 7, 8. So 8 down, and 1, 2, 3, 4, 5 over. So to get our hypotenuse, it'll be 8 squared plus 5 squared equals c squared. 8 times 8 is 64. 5 times 5 is 25. 64 plus 25 is 89. And the last step will be to square root both sides, which gives us an answer of square root of 89. Square root of 89 is a decimal, so this is perfectly appropriate. All right, so this is the exact same question as number 1, except there's no diagram or graph. So you can graph it if you want, or you can just look at this number, -5, and to 9. From -5 to 9, how far over do we go? Well, -5 to 0, that's 5 over. And then to 9 is 9 more over. So 5 plus 9 is 14. And then from -6 to -1. So from -6 to -1, that is 5 units over. So we get 5 squared. 14 squared is equal to 196, and 5 squared is 25. And 196 plus 25 gives us 221. And once again, we'll square root both sides. And the square root of 221 is also a decimal, so we are done with that. Okay, question 3 and 4. It's the exact same triangle. There's just 2 different methods we want you to use. The first one is Pythagorean Theorem. So we're checking to see if this angle right here is a right angle. So we're going to see if A squared plus B squared is equal to C squared. If it's equal, then we know we have a right triangle. The first step we need to do is to figure out how long all 3 of these sides are. So I'll do this first one from R to Q. So up, we're going 1, well, actually, let's draw it first. So we're going up 1, 2, 3, 4 up, and 1, 2, 3, 4, 5, 6, 7 over. So we get 4 squared plus 7 squared. 4 squared is 16, 7 squared is 49. 49 plus 16 is equal to 85. And that's equal to c squared, right? And so we square root both sides. So we get square root of 85 as our first side. Now let's go from R to S. Actually, do that in different colors so we can keep that straight. Let's do this one in dark green. So over and down. So we're going over 1, 2, 3, 4. And 1, 2, 3, 4, 5, 6, 7. So 4 and 7 again. We already know what that equals. We just did it over here. So it's the same answer. Square root 85. That's convenient. Remember, these are going to be squared, okay? We're using Pythagorean Theorem. Now our last one. Let's do this one in, let's go, I guess, orange. So from Q to S. So 1, 2, 3 down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we get 3 squared plus 11 squared. 3 squared is 9. 11 squared is 121. That adds to 130, and we square root it. So we're going to check to see if our left side equals our right side. So let's do some math. The square roots and the squareds, they cancel out all the way down. That's very convenient. So 85 plus 85. I just realized I made a mistake earlier. This is not 85. This is 65. Oops. So let's be 65, 65, 65. My mistake, sorry. So they all cancel out. 65 plus 65 equals 130. And this is 130. So therefore, it checks out. So yes, it's a right triangle. All right, this one, it's asking us to use opposite reciprocals, which means we're going to check the slope of both lines. So we're going to check the slope of this line and this line. So from Q to R, we're going up 1, 2, 3, 4, and over 7. So rise over run is 4/7. And then from R to S, we are going, so we'll run up from S. So 1, 2, 3, 4, 5, 6, 7 up. And then we go backwards, 1, 2, 3, 4. So this and this are opposite and reciprocals. So yes, they are perpendicular. Yes, QR is perpendicular to RS. You can put a line above that too. Oops, too far out. All right. Question 5 has 2 questions. Find the approximate area and perimeter of the triangle below. So I like to just draw a box around my shape. That's right there. Okay. First off, let's find the area of the box. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 wide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 times 10. That's the area of our box, which is 100. Now we're going to subtract some areas from it. Let's first do this big one. Well, we know the two sides are 10 by 10. And to find the area of the triangle, we divide that in half. So 10 times 10 is 100. We divide that by 2, which gives us 50. So we'll subtract 50. Let's do orange now. This area here is 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 times 6 equals 60. Divide by 2, we get 30. And that's it. We have no other triangles to subtract from. So 100 minus 50 minus 30 gives us 20. And that's the area. Now let's do the perimeter. I'm going to erase some of this stuff. Yeah, let's leave it like that, actually. Okay. So I'm going to find 3 of our sides. We have this side here. We'll use Pythagorean Theorem for. We already know it's 10 by 10. So 10 squared plus 10 squared equals our c squared. Both these are 100, which adds to 200, and we square root it. So that's one side. Now let's find the orange side. That side is 6 by 10. So 6 squared plus 10 squared is 36 plus 100, which adds to 136. And the square root of that is that side. And finally, we have one more side we have to figure out, which is actually the easiest one. It is a flat line. You just count it. 1, 2, 3, 4. So you'll put square root 200 plus square root 136 plus 4. Put that into a calculator, and you should get 29.8. Okay, so we have a shape. Let's plot this first. Check the time. 9 minutes in, okay. All right, so -7 is 1, 2, 3, 4, 5, 6, 7. And it's at 0. Then -4 and 3. And finally, -2. Finally, Now finally, -4, -2. Okay, that is our shape. I guess I could label it A, B, C, and D. All right. So it wants to know if it's a square, rectangle, or parallelogram. Well, I can look right now and tell that it's not a square. I'll show you a couple of things. From B to C, it's 2 down and 2 over. A to D, it's 2 down and 3 over. So this, if we do rise over run, the slope here is -2 over 3, and this is -2 over 4. So they're not the same size, nor are they the same slope. So honestly, just with that fact, we cross off all 3 things. So it's just a simple quadrilateral. So you can say the slopes aren't the same, and they're not the same length. So quadrilateral. Slopes do not equal, and sides do not equal. Okay, this is on a test. This is all I need to see. Draw it out and show me enough information, and then write something that proves that you know what you're talking about. Okay, one more of these questions. -4, 0. That's there. -7, -1. -5, 1, 2, 3, 4, 5, 6, 7, and -2, -6. Okay, so this is looking more like a rectangle, which would also be a parallelogram. It's definitely not a square, right? We can tell that our, let's actually plot everything. A, B, C, and D. Okay, it's definitely not a square. Because our B to C and A to D is longer than the other 2 sides. So square is off the books, but it does look like a rectangle and parallelogram. Let's do some math to confirm that. I agree. So from B, sorry, let me try enough space here. Actually, so from B up to A, we rise up 1 and run 3. So that's a slope of 1/3. And from C to D, that matches. And then from A to D, I'll do this in a different color, do it in green. We rise up 1, 2, 3, 4, 5, 6, and run -2. And then from C to B, 1, 2, 3, 4, 5, 6, and run -2. Oops, that should be positive. So we have this simplifies to -3, which would be over 1. This is already simplified. So these 2 things are both opposites and reciprocals. So they are perpendicular. We know that this matches with that, so they are parallel. And so these are perpendicular and they're parallel. We have both a parallelogram and a rectangle. All right, identify the center and the radius. Actually, I'm going to pause the video here and start a second one.